Today I'll be walking you through my KaggleX project, which is titled LearnBot. It's a conversational AI chatbot fine-tuned on Google's Gemma 2 model, and it's designed to guide users in their learning journey. It is also based on the Learning Paths Index created by the previous cohorts. My name is Moronfoluwa Akintola. I'm an MSc Data Science student at the University of Hertfordshire. I am also a machine learning intern at a Gen AI startup. Based on the Learning Path Index created by the previous cohorts, this project aims to develop a conversational AI assistant by fine-tuning the Google Gemma model to provide efficient access to structured learning data. This would enable users of all skill levels to retrieve tailored insights and skill development recommendations. The topics I cover during the course of my project includes NLP, RAG, LLMs, model fine-tuning, information retrieval. The platforms I leveraged includes Kaggle and Google Colab. Why Gemma 2B? The Gemma 2B is an instruct model that is designed and trained to follow and understand instructions. It is more responsive and accurate when completing tasks based on what a user asks it to do. There are other variants of the Gemma model, which are the Gemma 9B and the Gemma 27B, but they are designed to run on large servers or server clusters. The model I selected Gemma 2B because of the model's smaller size, which enables compatibility with resource constraints environments like the Google Colab platform, unlike its 9B and 27B counterparts. The initial model I considered was a 9B, but due to resource constraints and I was unable to work with it, I had to switch to the 2B, and I documented the errors I encountered during this process at the URL attached to this particular page. For my list of achievements, my first achievement was to create a Q&A dataset from the existing data. My second achievement was to fine-tune the Google Gemma 2B model, and my third achievement was to publish the model on Kaggle. My fourth achievement is to document my insights. For my first achievement, my objective was to transform the LPI datasets into structured conversational training data optimized for Gemma's instruction formats. The process I followed was to extract conversational patterns from the LPI data and convert them into Gemma instruction formats. The Gemma schema expects a JSON with instruction input and output field for natural dialogue generation, as illustrated in the template below. If you want to learn more about how I transform these datasets, you can find a link to this particular notebook on this page. Still on my first achievement, the original dataset was expanded from the structured course into an interactive Q&A dataset with compatible conversational AI system, and I've attached a screenshot to the initial dataset and the new records created to this particular page. For my second achievement, which is to fine-tune the model, my objective was to fine-tune the Gemma 2B model on the all pair dataset for course recommendation. The process I followed was to first set up the environment I need, and I prepared the environment by downloading the Gemma 2B model from the Kaggle platform and also the dataset I need, and pre-processed the Q&A pairs and applied LoRa-based fine-tuning technique with a sequence length of 512 and a batch size of 1. For the platform and the cost, I fine-tuned the model on the Google Colab platform for 20 AirPods, and I used the NVIDIA A100 GPU at a cost of at about $10 per month. I would like to accredit and acknowledge Gabriel Preda on his blog post that is titled Fine-Tuning Gemma 2 Model with Role-Playing Datasets. Why LoRa? So because I use LoRa in my model fine-tuning process, LoRa fine-tunes the AI model efficiently by adding small training models to specific parts, changing only 2 to 5% of the model while preserving its core abilities and saving computing resources. LoRa actually trains model in a shorter period and uses the least amount of resources while preserving the model original weight intact. If you want to learn more about LoRa technique, you can find these two links that I've attached to this particular page that is titled LoRa Research Paper and also Introduction to Guiding Fine-Tuning LLMs by the Data Campus platform. I have also attached a screenshot of my approach, loss, and accuracy while fine-tuning my model. The errors I encountered while fine-tuning my model. First, I encountered a GPU out of memory error on Colab while using GPUs like the L4 and the T4 and also TPUs as they lack sufficient memory for my parameters. But when I switched to the A100 GPU, this resolved the issue. I also encountered error LoRa target models do not match the pre-trained model's architecture. I updated the target model parameter to align with the actual model names to fix this particular error. For my third achievement, which is to publish the model, my objective was to publish the model on the Kaggle platform for community access. So the process I took was to package the model with its weight, config files, and documentation files, then publish it to the Kaggle platform using the Keras NLP package. If you want to access this notebook for inference, the links to the page is attached to this particular page. I have also included a screenshot to my Kaggle to my notebook that demonstrates how I interacted with the model. My learning process. First, I explored and implemented LoRa technique to fine-tune the general model for Q&A tasks. Second, I gained insight into handling dataset and optimizing model parameters for improved accuracy. And I also developed skills in deploying large language models. Finally, I collaborated with my mentors through Git for code review, feedback, and best practices. For my next steps and future work, I intend to web script additional LPI content and also automate the Q&A generation pipeline. Then to fine-tune the general model on the newly enhanced datasets that I will be creating, and then to build a real-time interaction with Fast API. Finally, to deploy the new model to Google Colab platform. The key outcome for my next steps is to deploy an efficient real-time learning assistant that will be accessible worldwide. I have attached links to my notebooks, my dataset, and the GitHub repository to this particular page. And I also added links to my external resources and other resources I used to learn during the course of this project. I would like to appreciate the Kaggle team for giving me the opportunity to work on this project, and I have big thanks to my mentors, Manishaka and Emmanuel Kachi, for their support during the course of my project. Thank you.